Hello everyone, today in this video we are going to talk about the combinations of cells, and we are going to compare different combination and we'll check which one is better. So we have two kinds of combination. The first one is series and second one is parallel. So many of the appliances need more than one cell and we have to combine this, and you might have seen used uh, this combination. So in the comment box tell me which combination you have seen in your real life, either it's series or it's parallel. So go to the comment box and give your answer and like the video as well. Okay, so series combination of cells. So let's do the series combinations of the cell. So I'm having two cells out here. So this is cell number 1 having EMF E1, internal resistance R1, and this is cell number 2, and current is flowing from this side, positive side of this first cell, and it is going to the negative side of cell 2. So current is flowing from cell 1 to cell 2. So I'll draw one more cell which I call it equivalent cell, so in which same current is flowing, and I have to find this R equivalent and R equivalent. So let's start the video. So we are considering two cells having EMF E1 and into internal resistance R1 and R2. So and I have considered one more cell which is equivalent cell. So out here I can say that potential difference across AB, so cell number 1, so I can write this to be VAB is EMF minus IR1. This relation we know, we have derived it in previous classes. So similarly, potential difference across cell number 2 BC, I can write VBC is equal to EMF minus current times R2. So as same current is flowing through both the cells, so I can write I, so I don't need to write I1 and I2. So now potential difference across AC can be written as potential difference from here to here. So this can be written as potential difference of cell 1 plus potential difference of cell 2. So I can write, so VA minus VC, that is the potential difference between these 2 points, is potential difference across cell 1 and potential difference across cell 2, that is BC. So that is VAB minus VAC. Now I'll put the value from here. So that is VAB is EMF 1 minus I R1 plus, so this is, you can say E also, so I'll be using E for this symbol for the time being. So it will be E2 minus I R2. So if I rearrange this equation, so taking EMF one side minus this IR1 minus IR2 together, so if you take the minus common, so it will be R1 plus R2 1. So I'm giving this as equation number 1. So if I use the same formula for equivalent circuit, that is VAC is, so this will be E equivalent minus IR equivalent. So I'm using the same formula for equivalent circuit. So now I'll compare equation 1 and equation 2. So this one VAC, both are VAC, so instead of equivalent I can write E1 plus E2. So if you compare this, E1 plus E2 will be E equivalent, and R1 plus R2 is R equivalent. So I got E equivalent and R equivalent. So if you have n number of cells, instead of having one cell, if you have n number of cell, so you can write E equivalent is E1 plus E2 plus dot 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 En, and R equivalent will be this one. So this is the formula for, so all the in series combination EMF will get added and internal resistance will also get added. So this is the total EMF is sum of, so same thing. So let's do for the parallel combination. So out here, so this is cell number 1 having EMF E1 and internal resistance R1, and cell number 2 having EMF E2 and internal resistance R2, and current flowing through cell number 1 is I1 and current flowing through cell number 2 is I2, and these two currents are getting added and making the current I. So that means I can write I is equal to I1 plus I2 because these two are getting added up and making the current I. So, and I'm making the equivalent circuit, so same is replaced by one cell having the EMF E equivalent and the resistance R equivalent, and current I is flowing. So these are two equivalent cells. So now these are the same thing I have explained. Okay, now for cell number 1 I can write V. So for these two cells, as they are connected in parallel, so potential difference between them will be equal. So I'll not write V1 and V2, I'll write V only because the potential difference across them is V. So I've already mentioned PD across AB is from here to here is V volt, whether you are talking about cell number 1 or cell number 2. So this is V is equal to E1 minus R1 I1. So as the current are different, so I can solve for I1. So this is I1 is E1 minus V by R1. So similarly I can write for cell number 2, that is I2 is E2 minus V by R2. So now, but the total current is given by I is equal to I1 plus I2. As you can see out here, these two current is added up to give I. So now I'll put the values. Now I'm putting the value of I1, that is E1 minus V by R1, and I2 is E2 minus V by R2. So I'm putting the values. So I'm separating R first and taking E one side, EMF one side, and taking this V one side. So I'm taking minus common, so this V will come out and your V will be, now I'm taking this V this side, so V will be E2 by R2 plus E1 by R1 minus this I will go this side, so it will become negative. Okay, now next step is, now I'm taking this, I'm simplifying this side, so it will be LCM of R1 and R2. So this way you can do. So now I'm just cross multiplying this to this side. So if you see this R1 and R2 will go to the numerator and R1 plus R2 will come to the denominator, and these two will get cancelled, and again I have to multiply this, cross multiply this with I also. So R1 R2 by R1 plus R2. Now again I'll just simplify this. So I got this V is equal to E2 R1 plus E1 R2 divided by R1 plus R2, and same thing. Now I'll put the formula for this equivalent circuit also. So I can easily write V is equal to E equivalent minus IR equivalent. So now I'll compare these two equations. So as V and V is same thing, so this and this will be equal, and I and I is same. So as the equation are same, so I can compare the variables. So if you compare this, so I'm writing again, so E equivalent will be this value, so and R equivalent will be this value. Now further this can be write in the simple form like this. So if you multiply this, take the LCM, again you will get the same thing. So whether you write this way or this way, it's same. And for this also, if you write 1 by R equivalent, you will get 1 by R1 plus 1 by R2. So for if you have n number of cells, so your E equivalent will be E1 by R1 plus E2 by R2 plus dot 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 En by Rn, and 1 by R equivalent will be 1 by R1 plus 1 by R2 plus dot 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 1 by Rn. Now you can see the difference. In series we have got just E equivalent is equal to E1 plus E2 plus E3, and R equivalent is equal to R1 plus R2 plus R3, but out here you can see that the formula is different. Now using this formula we'll check whether series combination is better or parallel combination. So see which is better. So for series, suppose, so this is the formula for series, and if all the cells are identical, means we are taking the cells of same value, same EMF and same internal resistance. So EMF for all, either it's E1, E2, E3, so En it is E only, and for resistance, whether it's R1, R2, it's R only. So now let's put the value. So out here it will be E plus E plus E plus n times, so that means it will be n times E, and same thing out here, if you add n times R, you'll get nr. So now let's see how much is the maximum current I can take out when this combination is connected to a resistor R. So now this is the formula for maximum current. Maximum current is total EMF by total resistance. So this is I is equal to, so this is total EMF, and total resistance is internal resistance plus the resistance you are adding to the circuit. So now if your R, the value of external resistance is more, okay, so internal resistance of the cell is very small, so if you are adding this to a very large resistance, that time see, so I max is, now I can ignore this NR, so you can write this, because if R is greater than NR, so your R will be this plus R will be just R only, because the value of R is more. So now I max is N E by R, but E by R is the current due to one cell, so that means I max is N times E by R, so that is Ni. So I is current due to one cell. So that means if you connect them in series, the cells, if you are connecting them in series, so you will get the N times the current due to one cell, so it is giving more current than, okay, starting it again. So if you connect n cells, so you will get the current due to n cells only, so that is good one. So let's check the parallel now. So in parallel we know the formula, so we are taking the identical cells, so as we have done before, so I don't need to explain this. So your E equivalent by R equivalent, I don't have the formula for E equivalent, so I have only E equivalent by R equivalent. So if you put the values, so E equivalent will be this, will be okay, I'm starting again for the parallel. So I'm doing the same for the parallel circuit. So your formula is like this, so E equivalent by R equivalent is like this, and 1 by R equivalent is 1 by R1, 1 by R2. So for n cells, suppose you are taking only cells of EMF E and internal resistance R, so this value E equivalent by R equivalent, that means you are adding E by R n times, so that means E by R into n. So E equivalent is equal to E by R n into R equivalent. Now let's find the R equivalent. So R equivalent is 1 by R equivalent is equal to 1 by R plus 1 by R2. So n times, if you are adding 1 by R, so you will get n by R. So your R equivalent is R by n. Now let's find the E equivalent, because there is R equivalent in the formula. So if you use this, so this E n by R into the value of R equivalent, that is R by n. So this n and R will get cancelled. So the EMF of n cells will be only the EMF of one cell, that is E. So now let's see how much is the maximum current if it is connected to the external resistance. So this is the maximum formula for maximum current. I max is equal to E by R plus small r by n. So you are taking the LCM for n, and this is the final expression. So this is the final expression. Now if R is greater than R, so this you can neglect this R, so this will be E by R n into n. So n will get cancelled, and you are getting only I. So E by R is I. So after adding the n number of cell, you are getting current due to one cell only. So whether you are connecting 5 cell or you are connecting one cell, you are getting the current due to one cell only, so this is not good. So but in series, if you are connecting 5 cells, you are getting the current due to 5 cells only, so the series one is better one, and we don't use the parallel connection, so we always use the series combination of cell. So out here you can see, so these are all 1.5 volt, 1.5 volt. So if you are adding 4 and you are getting only 1.5 volt, what is the use of adding 4? You can only use 1 point. So but if you connect them in series, you'll get 6 volt, so this one is better.